What if the strangest object in the entire solar system isn't a planet, a star, or even an asteroid, but something racing toward us right now from another star system? In July 2025, astronomers spotted 3I Atlas, only the third confirmed interstellar visitor we've ever seen, tearing through space at impossible speed. But almost immediately, scientists realized something wasn't right. Its glow was too bright, its chemistry too strange, and its behavior defied everything we thought we knew about comets. As the James Webb Space Telescope locked its instruments on the object, the readings only deepened the mystery. And now, with its closest approach just weeks away, researchers around the world are asking the same question. Is 3I Atlas just another cosmic snowball? Or could it be something far more extraordinary?
The story of 3I/Atlas began quietly, almost by accident. On July 1st, 2025, the Atlas Survey Telescope in Chile flagged a faint moving point of light, streaking just fast enough to stand out from the countless background stars. At first, it looked like any other distant comet candidate. But within days, orbital calculations revealed something jaw-dropping. This object wasn't circling the sun. It wasn't part of the asteroid belt. It wasn't even from our solar system. Its trajectory was hyperbolic, the unmistakable signature of something that came from deep interstellar space, visiting once before vanishing forever. Astronomers had seen this only twice before, in 2017 with the bizarre cigar-shaped Oumuamua, and again in 2019 with the icy comet Borisov. But there was something different about 3I/Atlas. Its incoming speed was higher than expected, racing toward the inner solar system at over 30 kilometers per second, fast enough to cross the distance from Earth to the Moon in under 4 hours. Even more intriguing, pre-discovery images from NASA's TESS satellite showed that 3I/Atlas had been active long before sunlight could have triggered it. A ghostly coma was already visible far beyond Jupiter's orbit, where most comets remain frozen and inert. Right away, astronomers knew this was no ordinary visitor. And the closer they looked, the stranger it became. Within days of its discovery, the world's most powerful observatories turned their instruments toward 3I ATS. The first surprise came from its chemistry. Using spectrographs tuned to split its light into a chemical fingerprint, scientists expected to see the usual mix of frozen water and dust. Instead, 3I ATS was dominated by carbon dioxide, not just a little, but in amounts far higher than almost any comet seen at this distance. There were traces of water and carbon monoxide too, but the ratios didn't match anything in our models. In other words, this thing wasn't just unusual, it was alien, chemically speaking. Even stranger was its activity. Normally, comets stay quiet until they get closer to the sun, when heat turns their ices into gas and forms the iconic glowing tail. But 3I ATS was already awake out near Jupiter's orbit. Its coma, the shroud of gas and dust around its core, was bright and steady, not flickering like a typical comet's jets. And it wasn't just glowing, it was glowing too much. Its brightness measured nearly 3 times what astronomers predicted for an object of its estimated size. Hubble and ground-based telescopes confirmed the result, ruling out instrument error. Whatever was powering this glow seemed to come from deep inside, not just the sunlit surface. That left researchers with an unsettling question. Was 3I ATS simply an unusually active comet, or was there something happening inside it that we had never seen before? As the weeks went by, the mystery only deepened. Astronomers tracked 3I Atlas night after night, mapping its brightness and rotation. What they found made even seasoned comet researchers uneasy. The light curve, the chart of its changing brightness, was almost perfectly flat. No dips, no surges, no evidence of the chaotic flickering caused by vents of gas shooting off in random directions. For most comets, that flicker is the signature of life, tiny eruptions that make them brighten and fade as they spin. But here, the glow was steady, almost mechanical,
like a lighthouse shining with clockwork precision. Hubble zoomed in on its coma, searching for the long, streaming tail that should have been forming by now. Instead, 3i Atlas was wrapped in a tight, teardrop-shaped shroud, more like a protective cocoon than a plume of escaping gas. Even its rotation seemed too regular. Estimates suggested a slow, deliberate spin, just enough to expose every side of the nucleus, but still producing the same constant glow. For researchers, the contradictions were piling up. A body too bright, too steady, and too self-contained to fit any familiar category. And then, just when the data couldn't get any stranger, the James Webb Space Telescope caught something that turned a weird comet into a full-blown mystery. When James Webb's infrared instruments locked onto 3i ATLS, they picked up something no one expected. A concentrated glow at its core. Not a hazy blur, but a tight, isolated heat source. At first, scientists thought it might be a trick of the data. They reran calibrations, cross-checked with Hubble and TESS, and still the signal was there. But the part that made researchers sit up was what came next. Every few hours, the glow seemed to pulse, swelling and fading in a slow, deliberate cycle. No random flicker, no chaotic outbursts, just a steady rhythm, like a slow cosmic heartbeat. The discovery set off a storm of speculation. Radio observatories tuned in, hoping to catch anything that might confirm or deny the idea that this object was more than a comet. After days of scanning, one team reported picking up a faint, narrow-band pulse repeating at the exact same interval as the thermal glow. Was it interference, a satellite glitch, or something real? Independent teams checked, and some claimed to see the same signal. Others dismissed it as background noise. But by then, the speculation had escaped the labs and hit the public. Was 3i ATLS just an unusually active comet, or could it be, as some whispered, a probe? Scientists were quick to warn that no evidence proved anything artificial. There were no confirmed transmissions, no clear sign of control or maneuvering, but the combination of its strange chemistry, its clockwork glow, and now a possible repeating radio pulse made the mystery impossible to ignore. And then came the flare. A sudden 40% jump in brightness coinciding with a subtle but measurable shift in its trajectory. To some, it looked like nothing more than a natural outburst. To others, it looked like a course correction. Now the countdown is on. In just weeks, 3i/Atlas will make its closest pass through the inner solar system. It's perihelion, giving scientists their best and possibly only chance to see it up close before it vanishes back into interstellar space, never to return. Every major observatory on Earth, from Chile's VLT to Hawaii's Keck, is lining up to capture every second of the encounter. Space-based instruments, Hubble, TESS, and of course the James Webb are already booked solid, watching for the slightest change in brightness, spin, or trajectory. And it's not just astronomers who are watching. Space agencies and SETI researchers are monitoring for any repeat of the faint radio pulse. The European Space Agency's Near-Earth Object Team has refined its models to track the comet's path with unprecedented precision, just in case the object does something unexpected again. For planetary scientists, this is more than just a curiosity. Each interstellar object is a messenger from a distant star system, carrying secrets about how planets and comets form in other parts of the galaxy. But for everyone else, the question is more primal. What exactly is heading our way? A perfectly natural visitor? Or the first sign that something out there is aware of us? Whatever 3i/Atlas really is, its next few weeks will decide whether it becomes just another data point or the most significant discovery in human history. Soon, 3i Atlas will be gone. It will slingshot past the sun, pick up speed, and vanish into the darkness between the stars, taking its secrets with it. Whatever it really is, we may only have days or weeks to gather clues before it's too late. That's what makes this moment so rare. We are alive at the exact time in human history when this object has chosen, or been forced, to pass through our neighborhood.
If it truly is just a comet, its perfect glow and steady spin will give us a new window into how icy bodies survive the brutal journey through interstellar space. But if there's even a chance it's something more, something built, not born, then this could be the single most important discovery we ever make. In the end, 3i Atlas is forcing us to confront a bigger question. What if we aren't the only ones leaving messages in the dark? One way or another, when this story ends, we won't just know more about this strange visitor. We'll know a little more about ourselves and about what kind of universe we really live in. So as 3i Atlas races toward its final moment in the sun, one thing is certain: the world is watching.